Alright, let's match functions a, b, c, and d with their corresponding derivative functions, capital A, B, C, and D. So if we look at graph A here, we can see that this is a constant negatively sloping line, right? So the derivative, first of all, it tells us that the derivative of this line should be negative. So it should be below the x-axis, right? And also the fact is that the derivative should be constant because a line has a constant slope. So the only solution for A would be C. Okay, so this would be graph C, right? Because we can understand here that the slope here, right, if I take 2 points, right, whoops, what happened there? If I take 2 points, so if I take this point and let's say this point, you can see that the slope here is -3 rise, run is 1. So the slope looks like -3. And the only thing that kind of works with that, you can actually see that the slope here, y is equal to -3. Right, so not only is the slope negative, it's below the x-axis, but we actually get the right value. So the A has to be graph C. Now let's take a look at graph B. We can understand here that this is a parabola. This point here is what we call, this is a minimum. And the slope of a minimum, it should be 0. Okay, so the derivative function will actually have a 0 at this point. Okay, so it will actually have a 0 at 1. Okay, and we can notice here that from 0, from this point, 1 onward, so from -infinity, from -infinity to 1, you can see there's a negatively sloping line, right? So you can see that there's a negatively sloping line here, but from 1 to positive infinity, right, we have a positively sloping line here, okay? So which one would satisfy that scenario, right? So really the only one that seems to satisfy that scenario, we want to find a derivative function. Well, the only one that would actually kind of work would be basically graph A, right? And as you can see here that there is, at 1 there's 0, right? From 1 to positive infinity, this is positive, so this is in the positive slope, which is right. Right, so remember, this is the slope function. The slope is positive from 1 to positive infinity, and the slope is negative from negative infinity to 1. Okay, so that's basically what it means by positive negative slope. In terms of the slope or the derivative function, you can see that the positive slope would be above the x-axis, the negative slope would be below the x-axis. Okay, so keep that in mind. So that means that graph B definitely has to be lowercase b should be graph A. Okay, let's take a look at graph C. You can notice here that so there is a minimum point here and a maximum point here, right? Minimum and maximum points actually have a slope of 0. Okay, so there should be a 0 point at -1. There should be a 0 point at 0, and there should be a 0 point technically close to positive 1. Okay, and the only one that really has that, right, there's a 0 here, and at close to -1 there seems to be a 0 here, and the close to positive 1 there's a 0 there, right? So it's a little bit close to that. Also, you can test the points here. Let's say that this is like 1. It's slightly a little bit past 1, but let's do 1 in positive infinity. There's a positive slope here. Okay, and you can see that there's a negative slope here from negative infinity and 1-ish, -1. Right, so from negative infinity and -1, from negative infinity and -1, there should be a negative slope. You can kind of see that here, right? See, there's negative slope from negative infinity to, this kind of looks like -1, right? And so all of this portion here, that's negative infinity, -1. And you can also see that from positive 1 onwards, right, so 1 and positive infinity, you can see that there's a positive slope like what we intended here, and between 1 and 0 we see a positive slope here, right? So 1 and 0 you actually see a positive slope. Sorry, -1 and 0 you should see a positive slope. I'm making a lot of mistakes today. And from 0 to -1 you should see a negative slope. So this is kind of consistent with C and D, right? So lowercase c should be corresponding to graph D, and by default, right, lowercase d should be corresponding to graph B. Okay, and let's just test it just for kicks. But you can understand here that there's a maximum point, there's a minimum point, right, and you can see that these correlate with the zeros. Okay, now you can actually see that the derivative has a maximum point, and this actually will be referred to as a point of inflection. A point of inflection where you have a chain concavity appears as a maximum or minimum point on the derivative function. We'll discuss this more when we study curve sketching, right? But you can also notice that, okay, if this is 0.5 here, if this is 0.5, then between negative infinity and 0.5 we have a negative slope. You can actually see that here. See, negative infinity to 0.5, the graph is below x, right? So you can notice here that, right, from here to here, negative infinity to 0.5, the graph is below x. So all of those pieces will just kind of point in that direction. So you can kind of see how this gets put together. And we're going to be looking at more of these questions when we look at the curve sketching unit in future chapters.